There are many situations where it is possible to simplify our design down to a 2D version and still get very accurate results. And in 2011 we've implemented planar 2D simplification to provide us with the ability to do this. Not just for linear runs, in other words things that don't yield or deform too much, but even for those non-linear areas where we get plastics deformation or large deformation. When we create a study in SolidWorks simulation, we now have the 2D simplification option. If we select that, all we need to do is pick a plane that we'd like to slice our model with. In this case, for something that's a revolve, I can use axis symmetric to get a simple slice of the revolve profile. I can then use this profile to check out the performance of our design. So let's just have a look at that. So you can see here we have our seals and our top and lower plates. As for any other model, all the material properties come across automatically for us. All we really have to do is define a couple of additional contacts between the edges that are going to touch, and we'll do that for the other seal as well. And that's really all there is to it that's different. We apply a fixture to hold our geometry as we would normally, and then we apply some way of applying the load. In this case, what I'm going to do is pull down on the top 10 millimeters to clamp our system. Again, great visual feedback to understand what's going on there. One of the great things about doing a 2D simplification is that we can really provide a very refined mesh with very little overhead. There's just no way you could come in and do a solid model of this design and get results in a reasonable time frame, as well as when you look at the amount of memory and disk space it can consume. So 2D simplification is a real time saver and actually can give you more accurate results than you can achieve with a solid model. And if you think of that with nonlinear analysis, that's a real big time saver. So you can see this one only takes a few seconds to solve. It's not bad at all, and the same sort of benefits apply to any form of analysis. And 2D simplification is supported for thermal as well. So you can see here we have our results. We've got this deformation. We can animate the results. Not only that, we can even control the results view to actually show it on a solid portion of the model, which is great for assisting in visualizing what's going on. And it's not just a static image. Again, we can animate that. So again, it's great feedback to enable you to look at different elements. So this is a linear model. Let's have a look at a nonlinear solution. Here we have a latch system, and what I'm interested in is the performance of the latch and how it's going to open up as it goes over this pin. Again, we can do a 2D slice to look at the area of interest, which is the latch itself. So let's have a look at that. Again, because these are parametric, you can go in and modify them at any time. So you can see here, that's the 2D profile or the slice we're doing through the model, and that all we do is specify the thickness of the area of interest, which is the thickness of the latch. Again, materials come across. In this case, we're just doing a global contact, just saying those two bodies cannot penetrate each other. And we've got a mesh control. And again, there's just no way with a solid model you can come in here and do a refined mesh to get accurate results the way we can with planar simplification. So there's our result. Let's animate it. And again, nice visualization. If we look at the solve time for this one, it's only just over a minute. And again, same thing. We can show it in 3D as well. So again, it's not only more accurate, it's going to be faster, and that means you're getting the right answers the first time. So planar simplification is going to be very beneficial to those people that have some sort of symmetry in the models and helps reduce the time it takes to get more accurate results.